From steam engines that turned workers into scalded corpses, to dynamite that buried entire crews alive, to assembly lines that drove people clinically insane, these are the industrial inventions that changed the world forever. And some of them were so brutal you'll be shocked they're not considered war crimes. Like the power loom, which revolutionized textile production in the early 1800s, but also created factory conditions so horrific that workers regularly got their hair caught in machinery and were scalped alive. They were breathing in cotton fibers that destroyed their lungs by age 25. But hey, at least your cheap t-shirt only cost a few lives, right? 'Cause progress has always come with a body count. Let's dive into the chaos. 'Cause those textile machines didn't just revolutionize cloth production, they created death traps staffed by children. The spinning jenny, invented by James Hargreaves in 1764, could spin 8 threads at once instead of just one. Sounds like progress, right? Wrong. Factory owners realized that small hands were perfect for reaching into tight spaces when threads broke, so they hired kids as young as 6 years old to crawl underneath spinning machinery while it was still running. And when a child's hair got caught in the gears, well, scalping was just part of the job. By the 1830s, over 50% of textile workers in Britain were children under 13. They worked 14 to 16-hour shifts, 6 days a week, for pennies. And the factory conditions? Imagine a building with no windows, cotton dust so thick you couldn't see 3 feet ahead, and machinery that would rip your arm off if you hesitated for even a second. Breathing in that cotton fiber gave kids a disease called brown lung, which slowly suffocated them by their mid-20s. But hey, at least your grandma's wedding dress was affordable. Talk about a rough childhood. But if you think textile mills were bad, wait till you hear about steam engines. 'Cause in the early 1800s, inventors figured out how to harness steam power to drive machinery. Revolutionary. One steam engine could do the work of 50 horses. The problem? Boilers exploded. Constantly. Between 1817 and 1848, there were over 2,000 reported boiler explosions in the United States alone. And we're not talking about small pops. These were catastrophic eruptions that launched multi-ton pieces of metal hundreds of feet into the air, killing everyone within a 50-foot radius. In 1830, a boiler explosion on a train in South Carolina killed the fireman instantly when a flying piece of iron decapitated him mid-shift. And this wasn't even unusual. Early steam engines had zero safety regulations, no pressure gauges, and definitely no emergency shutoff valves. Engineers would just keep shoveling coal into the furnace, cranking up the pressure, and hoping for the best. Imagine your Uber driver disabling the airbags because they wanted to go faster. That's basically what happened every single day. Ouch. But speaking of disasters waiting to happen, we can't forget Eli Whitney's cotton gin. Invented in 1793, the cotton gin could clean cotton 50 times faster than a human hand. One person operating the machine could do the work of 50 enslaved people, and you'd think, great, now we don't need as much forced labor. Nope. The exact opposite happened. 'Cause the cotton gin made cotton so insanely profitable that southern plantation owners massively expanded their operations. Before the cotton gin, the U.S. produced about 750,000 pounds of cotton per year. By 1820, over 160 million pounds annually, and all that cotton required more enslaved people, not fewer. Between 1790 and 1860, the enslaved population in the U.S. exploded from 700,000 to nearly 4 million people. So an invention designed to reduce labor actually fueled one of history's darkest economic systems. Whitney definitely didn't see that coming. Talk about unintended consequences. But while workers were losing limbs in factories, Inventors were losing their minds trying to revolutionize transportation, 'cause for thousands of years humans moved at the speed of a horse. Walking, riding, sailing. That was it. Then, in the early 1800s, engineers figured out how to strap a steam engine to wheels, and suddenly we had locomotives that could hit 30 miles per hour. People absolutely lost their minds. Doctors warned that traveling faster than 20 mph would cause your brain to melt. Clergymen claimed locomotives were inventions of the devil, and some people genuinely believed that going 30 mph would make your blood boil and your eyeballs explode. This was a real fear. Imagine thinking your body would literally disintegrate because you went slightly faster than a galloping horse. But the real danger wasn't speed. It was the fact that early trains exploded, derailed, and killed passengers with shocking regularity. On September 15, 1830, at the grand opening of the Liverpool and Manchester Railway, British Member of Parliament, William Huskisson became the first train passenger ever killed, and not in some freak accident. Dude just stepped onto the tracks to chat with the Duke of Wellington, didn't notice the train coming, and got run over at the opening ceremony. For the train. Talk about a bad first impression. But if trains were death traps on land, steamboats were floating bombs on rivers. 'Cause between 1825 and 1855, there were over 230 steamboat explosions in the United States alone. And these weren't minor accidents. When a steamboat boiler exploded, it could launch the entire smokestack 300 feet into the air, split the boat in half, and spray scalding steam across anyone nearby. In 1865, the steamboat Sultana exploded on the Mississippi River, killing an estimated 1,800 people. That's more deaths than the Titanic. And why did they explode so often? 'Cause steamboat captains were racing each other for bragging rights. They'd tie down the safety relief valve, crank the pressure as high as possible, and just pray the boiler held together. Spoiler alert, it didn't. Imagine your Uber driver disabling the airbags and seatbelts because he wanted to beat his personal best time. That's what steamboat travel was like in the 1800s. Insane, but even when you survived the journey, you still had to deal with the bicycle, or as it was lovingly called in the 1860s, the bone shaker. 'Cause early bicycles had wooden wheels, no suspension, and absolutely no brakes. Riding, one felt like sitting on a jackhammer while careening down a cobblestone hill with zero ability to stop. People regularly crashed into buildings, flew over the handlebars, and shattered their teeth on the pavement. But the real controversy wasn't the injuries. It was the moral panic. Victorian doctors claimed that women riding bicycles would damage their reproductive organs. Some even insisted that cycling caused insanity, nymphomania, and moral corruption. Yeah. Sitting on a bike was apparently enough to turn you into a lunatic, but if you think early transportation was a death trap, wait till you see what happened when inventors decided to light up the world. 'Cause when people were tired of exploding on trains, they decided to light up their homes with something even more dangerous: gas. Before the 1800s, most people used candles or oil lamps, which were dim, smoky, and required constant maintenance. Then coal gas lighting arrived in the early 1800s, and suddenly you could illuminate an entire room with the flick of a valve. The problem? Gas leaks, explosions, carbon monoxide poisoning, and houses burning down at an alarming rate. In London alone, between 1815 and 1840, there were hundreds of gas-related explosions annually. Pipes were poorly sealed, valves were unreliable, and people had zero understanding of how dangerous this stuff was. You'd go to bed, a pipe would crack overnight, gas would fill your bedroom, and by morning you'd either be dead from asphyxiation or your house would explode the moment someone lit a match. In 1846, a gas leak at a theater in Quebec caused an explosion that killed 46 people during a performance. The entire building went up in flames in minutes. But hey, at least you didn't have to squint by candlelight anymore. And if gaslighting was a gamble, early electricity was straight-up Russian roulette. 'Cause in the 1880s, Thomas Edison and Nikola Tesla were locked in what became known as the War of the Currents. Edison championed direct current, DC. Tesla backed alternating current, AC. And Edison, being the ruthless businessman he was, decided the best way to prove AC was dangerous was to literally electrocute animals in public demonstrations. Horses, dogs, even an elephant named Topsy. Edison electrocuted them all to prove that AC current was deadly. Then he took it a step further and helped develop the electric chair to execute criminals with AC power, hoping it would forever associate Tesla's technology with death. The first electric chair execution was William Kemmler in 1890, and it was an absolute horror show. The first jolt didn't kill him. Kemmler remained conscious, groaning and convulsing, so they hit him with a second jolt. For 8 agonizing minutes, witnesses watched as Kemmler's body smoked, his skin burned, and the smell of charred flesh filled the execution chamber. One reporter called it far worse than hanging. But Edison got his headline. AC current was the killer. Literally. Talk about a publicity stunt gone wrong. But while Edison and Tesla were duking it out, regular people were just trying not to die from their new light bulbs. 'Cause early incandescent bulbs weren't just fragile. Some of them contained toxic materials that could shatter and spray mercury or other chemicals across your living room. Edison himself tested over 3,000 different filament materials, many of which were flammable, explosive, or outright poisonous. His lab caught fire multiple times. Assistants suffered burns and chemical exposure, but eventually he found carbonized bamboo, which worked. Kind of. So next time your light bulb burns out, be grateful it's not filled with toxic gas or liable to explode in your face. But speaking of lighting up the world, let's talk about how people actually started communicating across vast distances. 'Cause for thousands of years, if you wanted to send a message, you had 3 options. Write a letter and wait weeks for it to arrive, send a messenger on horseback, or use smoke signals and hope nobody misunderstood. Then, in 1844, Samuel Morse sent the first telegraph message, and everything changed. The message? What hath God wrought? Dramatic, right? But also incredibly accurate. 'Cause the telegraph didn't just speed up communication, it fundamentally altered warfare, business, and daily life. During the American Civil War, President Lincoln used the telegraph to coordinate troop movements in real time. Generals could receive orders within minutes instead of days. And by the 1860s, telegraph operators had developed something wild. They could identify each other by their unique tapping rhythm, called a fist. You could literally recognize someone just by how they hit the telegraph key. Imagine being able to identify your coworker by the sound of their typing. That's how intimate telegraph communication became. But the real magic happened in 1876, when Alexander Graham Bell invented the telephone. And the first words ever spoken over a phone line? "Mr. Watson, come here. I want to see you." Why? Because Bell had just spilled acid on himself during the experiment and needed help. So, the most revolutionary communication device in history was born out of a lab accident. Classic. But people didn't immediately embrace the telephone. In fact, many thought it was witchcraft. How could a voice travel through a wire? Some claimed it was demonic possession. Others refused to use it out of fear that their soul would get trapped inside the device. And doctors actually diagnosed people with telephone phobia, a real medical condition where patients believed using the phone would cause physical harm or mental breakdowns. Imagine thinking a telephone would steal your soul. By the early 1900s, radio took communication even further. In 1901, Guglielmo Marconi sent the first transatlantic radio signal from England to Canada. Just 3 dots, the letter S in Morse code, and suddenly voices could travel through the air without wires. People lost their minds. Some thought radio waves were physically dangerous. Others believed hearing voices from invisible sources meant the speaker was possessed by spirits. But the real proof of radio's power came on April 15, 1912, when the Titanic struck an iceberg and sank in the North Atlantic. The ship's radio operator, Jack Phillips, sent out desperate SOS signals for hours. Ships hundreds of miles away picked up the distress calls and raced to the scene. Thanks to radio, 700 people were rescued. Without it, everyone on board would have died, and the world wouldn't have known about the disaster for days. Talk about mixed signals. Radio could save lives, but it also broadcast disasters in real time, forcing people to confront tragedy as it unfolded. But if you think communication technology was revolutionary, wait till you see what happened when inventors decided to literally reshape the Earth. 'Cause while people were sending telegrams and making phone calls, engineers were literally moving mountains. And the key to all of it? Dynamite. Before Alfred Nobel invented dynamite in 1867, construction projects relied on black powder, which was unpredictable, weak, and prone to accidental detonations. Nobel's nitroglycerin-based explosive was 3 times more powerful and far more stable. It revolutionized mining, tunneling, and large-scale construction. But here's the twist. Nobel's younger brother, Emil, died in a nitroglycerin explosion at their factory in 1864. The blast killed 5 people and devastated Alfred. Then, in 1888, a French newspaper mistakenly published Alfred's obituary instead of his brother's. The headline, "The Merchant of Death is Dead." The article condemned him for inventing a substance that enabled mass killing in warfare. Nobel was horrified. He didn't want to be remembered as the man who made it easier to blow people up. So he used his fortune to establish the Nobel Prizes, including the Nobel Peace Prize, to redeem his legacy. From merchant of death to champion of peace. Talk about a guilt-driven redemption arc. But while Nobel was wrestling with his conscience, his invention was killing thousands of workers. The construction of the Panama Canal between 1904 and 1914 killed over 25,000 people. Dynamite blasts went wrong constantly. Workers were buried alive in landslides triggered by explosions. Others died from malaria, yellow fever, and horrific accidents involving unstable dynamite in tropical heat. One wrong move, one spark, and an entire crew could be vaporized. And let's not forget the workers who didn't die from explosions, but from sheer exhaustion and disease. The Panama Canal wasn't just an engineering marvel, it was a mass grave. But dynamite wasn't the only game changer. The steam shovel, invented in the 1830s and perfected by the 1880s, allowed engineers to move Earth on a scale previously unimaginable. One steam shovel could do the work of 100 men with shovels. The Suez Canal, completed in 1869, and the Panama Canal both relied heavily on steam-powered excavators to carve through millions of tons of rock and dirt. But the human cost was staggering. Workers operating steam shovels were crushed when machinery malfunctioned. Others were buried alive when tunnel walls collapsed. During the construction of the Brooklyn Bridge between 1869 and 1883, over 20 workers died. Some fell from scaffolding, others were crushed by falling cables, and several developed a mysterious illness called the bends, caused by working in pressurized underwater chambers and surfacing too quickly. Their blood literally bubbled, causing paralysis, excruciating pain, and death. The bridge's chief engineer, Washington Roebling, was partially paralyzed by the bends and had to supervise construction from his apartment window using binoculars. His wife, Emily Roebling, took over much of the day-to-day management, making her one of the first female field engineers in history. But the fact remains, that iconic bridge was built on the broken bodies of dozens of workers. So next time you're stuck in traffic crossing a bridge, just remember someone probably died building it. But while construction workers were falling from bridges, factory workers were about to face something even more soul-crushing. 'Cause in the late 1800s, steel production exploded thanks to the Bessemer process, invented by Henry Bessemer in 1856. Before Bessemer, making steel was slow, expensive, and labor-intensive. His process could convert molten iron into steel in just 20 minutes instead of hours or days. Suddenly, steel became cheap and abundant, and that changed everything. Steel rails crisscrossed the country. Steel beams allowed skyscrapers to rise. Steel machinery powered factories. But the human cost? Absolutely brutal. Bessemer steel mills were infernos. Workers stood next to furnaces reaching 3,000 degrees Fahrenheit. Molten steel could splash, causing horrific burns. If a furnace exploded, everyone within 50 feet was either incinerated or maimed. In 1892, a Bessemer converter exploded at a mill in Pennsylvania, killing 11 workers instantly and injuring dozens more. And this wasn't rare. Steel mill accidents were a regular occurrence, but the Bessemer process made Andrew Carnegie insanely rich. By the 1890s, Carnegie's steel empire dominated the industry, and he became one of the wealthiest men in history. Meanwhile, his workers toiled in conditions that would make modern OSHA inspectors faint. But if steel production was brutal, the assembly line took workplace misery to a whole new level. In 1913, Henry Ford revolutionized manufacturing by introducing the moving assembly line at his Model T factory. Before the assembly line, building a car took over 12 hours. After, just 93 minutes. 93 minutes. Insane. But here's what Ford didn't advertise. The assembly line was a psychological nightmare. Workers stood in the same spot for 10 to 12 hours a day, repeating the same motion hundreds of times. Install a bolt, tighten, move to the next car, install a bolt, tighten, repeat. All day, every day. No variation, no creativity, just mechanical repetition. And the turnover rate? A staggering 370% annually. That means Ford had to hire 3 new workers for every 1 position just to keep the line running. People quit constantly because the work was so mind-numbingly monotonous they couldn't take it. Some workers developed repetitive motion injuries. Others suffered psychological breakdowns. Doctors even coined a term for it, Forditis, a condition marked by extreme exhaustion and mental fatigue caused by assembly line work. Talk about soul-crushing efficiency. Ford's solution? Pay workers more. In 1914, he introduced the $5 workday, which was double the average factory wage. But this wasn't generosity, it was damage control. Ford needed to reduce turnover and keep the assembly line moving, and it worked. Workers stayed because they couldn't find better pay anywhere else, even if the job slowly destroyed their mental health. So next time you complain about your boring job, at least you're not installing the same bolt 500 times a day while Henry Ford times you with a stopwatch. 'Cause by the early 1900s, humanity had conquered land, sea, and industrial production. So naturally, they decided to conquer the sky. On December 17, 1903, Orville and Wilbur Wright achieved the first powered flight in Kitty Hawk, North Carolina. The flight lasted 12 seconds and covered 120 feet. That's shorter than most commercial airliners today. But those 12 seconds changed everything. Within 5 years, airplanes were being tested for military use, and within a decade, they were dogfighting over Europe in World War I. But early aviation was a death sentence. Planes were made of wood, canvas, and wire. Engines failed constantly. There were no parachutes, no ejection seats, and definitely no safety regulations. If your plane caught fire mid-flight, you burned alive or jumped to your death. Those were your options. In 1908, Lieutenant Thomas Selfridge became the first airplane crash fatality when a propeller blade broke during a demonstration flight with Orville Wright. The plane plummeted 75 feet and crashed. Selfridge died from a fractured skull. Orville survived with a broken hip and several fractured ribs. And this was just the beginning. During World War I, the average life expectancy of a fighter pilot was 2 weeks. 2 weeks. You'd get basic training, climb into a flimsy biplane, and within 14 days, you were either dead or so traumatized you couldn't function. Pilots didn't die from enemy fire alone. Planes disintegrated mid-air. Wings snapped off. Engines exploded. And if you survived the flight, you still had to land the damn thing, which was basically a controlled crash. But while pilots were plummeting from the sky, automobiles were killing people on the ground. Henry Ford's Model T, introduced in 1908, made cars affordable for the average American. By 1920, there were over 8 million cars on U.S. roads. The problem? Zero safety features. No seatbelts, no airbags, no crumple zones. If you crashed, the solid steel steering column would impale you through the chest. Windshields were made of regular glass that shattered into deadly shards. And brakes? Primitive at best. Early cars could barely stop on. Dry pavement, let alone in rain or snow. Cities scrambled to create traffic laws because cars were mowing down pedestrians at an alarming rate. In 1920s New York, the speed limit was 10 miles per hour in residential areas. Drivers routinely ignored it. By 1930, car accidents were killing over 30,000 Americans annually. That's more than died in some wars. Imagine buying a car with zero safety features and just hoping for the best. But if cars and planes were dangerous, household electricity was downright lethal. Early appliances like toasters, washing machines, and electric irons had exposed wiring and zero insulation. People were electrocuted in their own kitchens. In 1925, a woman in Chicago died when her electric hair curler short-circuited while she was using it in the bathtub. Another man was killed by a faulty radio that electrocuted him when he adjusted the antenna. So, yeah, modern life was trying really hard to kill you in creative ways. 'Cause the 20th century wasn't done trying to kill people. By the 1940s, humanity had invented something so powerful it could end civilization itself: nuclear weapons. On August 6, 1945, the United States dropped an atomic bomb on Hiroshima, Japan. 3 days later, another one hit Nagasaki. The combined death toll? Over 200,000 people, most of them civilians. Many died instantly, vaporized by temperatures hotter than the surface of the sun. Others died slowly from radiation poisoning over the following weeks, months, and years. The Manhattan Project, led by physicist J. Robert Oppenheimer, had successfully weaponized the atom. And after witnessing the destruction, Oppenheimer famously quoted Hindu scripture, "Now I am become death, the destroyer of worlds." But here's the irony. Nuclear technology was later repurposed for energy. Nuclear power plants promised clean, abundant electricity. Then came Chernobyl in 1986. A reactor exploded in Ukraine, releasing radioactive material across Europe. 31 people died immediately. Thousands more developed cancer. An entire city, Pripyat, was abandoned overnight. And the exclusion zone around Chernobyl remains radioactive to this day. So we invented a technology to save the world, and accidentally created disasters we're still dealing with decades later. Talk about a double-edged sword. But while nuclear power was irradiating Eastern Europe, another invention was quietly transforming daily life: plastics. In the 1950s, plastic production exploded. Suddenly, everything was made of plastic: toys, containers, packaging, furniture. It was cheap, durable, and revolutionized consumer goods. But here's the problem: plastic doesn't decompose. Ever. By the 1970s, scientists were finding plastic debris in the oceans. By the 2000s, massive garbage patches the size of Texas were floating in the Pacific. And in 2024, researchers discovered microplastics in human bloodstreams. That's right, the invention that made life convenient is now literally inside your body. Every time you drink from a plastic bottle or eat food wrapped in plastic, you're ingesting microscopic particles that will outlive you by centuries. So the invention that saved the world is now slowly poisoning it. Great job, humanity. But if plastics were an accidental disaster, computers and the Internet were intentional game changers. In 1945, the ENIAC, the first general-purpose electronic computer, filled an entire room and weighed 30 tons. It could perform 5,000 calculations per second, which seemed miraculous at the time. Fast forward to today, and your smartphone is millions of times more powerful and fits in your pocket. The Internet, developed in the 1960s for military communication, became publicly accessible in the 1990s, and within 20 years it connected billions of people. Social media, email, instant messaging. The world became smaller, faster, and more connected than ever before. But here's the twist. We invented a machine to connect humanity, and we used it to argue about everything. The average person now spends over 7 hours a day staring at screens. Social media addiction is real. Mental health issues among teenagers have skyrocketed, and misinformation spreads faster than the truth ever could. So, we built a tool to bring people together, and it's tearing us apart. Classic. And there you have it. Every industrial invention that changed the world forever. From child labor in textile mills, to nuclear disasters, to microplastics in your bloodstream, progress has always come with a brutal price. And if you thought that was disturbing, wait till you hear about the inventions that almost made it to market but were too dangerous to release. From weaponized weather control to experimental brain implants gone wrong, click this video right here and prepare to be horrified.